Welcome back. This is part 2 of geometric mean. So for this first part we're going to be dealing with a few theorems. We have 3 theorems today. So theorem 7.1, if the altitude is drawn, so remember an altitude is perpendicular to the opposite side and goes through a vertex. It says if the altitude is drawn from the vertex of the right angle of a right triangle, so here's my right angle, to its hypotenuse. So here's my hypotenuse. So we have our right angle here, so that makes it an altitude. Then the 2 triangles that are formed, I have one here and one over here, are similar to the big triangle that was given and to each other. So it's telling us when we make an altitude from the right angle to the hypotenuse, so it's perpendicular, then we create 3 similar triangles. The 2 little ones, and then the large one. So triangle XYZ is similar to triangle XWY, which is similar to triangle YWZ. The helpful piece to this is if we know one of these is a special triangle, like our 30-60-90 or our 45-45-90, then we know the other 2 are as well. So that can be very helpful for us. And then the other thing is, since they're similar, we can set up those proportions to be able to find the other pieces. Okay? So looking at the next one, 7.2, the measure of an altitude drawn from the vertex of the right angle of a right triangle, so we're using this same picture here, so vertex of our right angle to the hypotenuse. Okay, so the vertex of the right angle of a right triangle to its hypotenuse is the geometric mean between the measure of the 2 segments of the hypotenuse. So these 2 segments, it's the geometric mean of those. Okay, so when we're looking at this picture, we have YW, that's our altitude, is the geometric mean of the 2 pieces of the hypotenuse that were created, which is XW and ZW. Okay, so just like we were doing in part 1, where you were finding the geometric mean of 2 numbers, whatever those 2 numbers are, we could use these 2 segments and substitute them in for A and B and be able to find X, which is our YW. Okay, we have one more theorem and then we'll do some examples. I'm using the same picture for all 3, so you only have to draw that once. Alright, so the last one then says if the altitude is drawn from the vertex of the right angle of a right triangle to its hypotenuse, okay, so that's what we had in the picture that's up above here, then the measure of a leg of the triangle is the geometric mean between the measure of the hypotenuse and the segment of the hypotenuse adjacent to that leg. Okay, so we're looking here. So it says we have our altitude, says that the measure of a leg, so let's take YZ for instance, the measure of this leg is the geometric mean between the measure of the hypotenuse, so the whole hypotenuse, and the segment of the hypotenuse that is adjacent to that leg. Well, which one's adjacent to this one? That's this piece. Okay, so we have XZ and WZ are our 2 pieces for the YZ. So we're going to come down here, and if you look, I have XZ and WZ are my 2 pieces, and the geometric mean is the ZY, or YZ. We could also do the other one. So if we did this leg here, which is XY, then our 2 pieces would be, again, the XZ, but this time we would use XW. So if you look down here, I have my XY's, that's my geometric mean, and then the 2 numbers, I have XZ, which is the whole hypotenuse, and XW, which is the piece that's adjacent. That's right here, the adjacent one. Alright, so let's get into some examples. Alright, so the first part we had example 1. So we're going to start with example 2 today. So I have a picture here. This is our triangle. So we have a right triangle here, which is RPQ, and then we have an altitude which is drawn. And it's telling us here in this triangle that we have RS is 3. So we're going to label that with 3. Let me see if I can zoom in just a little bit here for you. So RS is 3. And then it also tells us QS is 14. So this piece is 14. So then we are going to use X for PS. That's this here. And that's what we're trying to find. So if you remember 7.2, we're going to look back at that one. 7.2, it told us that the measure of the altitude for the right triangle, then we have the geometric mean between the measures of those two segments of the hypotenuse. Okay, so this piece here, which we said was X, is the geometric mean between these two pieces. Okay, so then when we look over here at example 2, PS is the geometric mean between these two pieces. So we set it up RS over PS. Remember, these two, the bottom here and the top over here, those are your geometric means. So PS equals PS over the other piece, which is QS. So I'm going to plug in some numbers. RS we said was 3 over PS we said was X equals PS is X again over QS, which is 14. So then we're going to be doing our cross products. So we get X squared equals 3 times 14, which is 42. Okay? So then from there, we're going to be taking the square root of our x squared equals the square root of the 42. So we end up with x equals, and let's see, that's going to be approximately, I'm going to plug that into my calculator because it's not going to come out evenly. So that's approximately 6.5. Okay, so PS is approximately 6.5. Okay, and again, I just punched this into the calculator because this was not a perfect square, and I came up with the 6.5. And then I used my little squiggles because I want it to be approximate. It's not an exact answer. Alright, let's go on to another one. This is example 3. So for this one, I drew this picture of a tree over here. So I have this picture of a tree, and I have this person is standing down here, and he's looking up here to the top of the tree, which is Z. And he is 5.5 feet tall. So he's 5.5 feet tall, and he's standing 8 3/4 feet from the base of the tree. So 8.75 feet from the base of the tree. Okay, so we're going to find the distance from the very top of the tree all the way to the ground, and that is WZ. Okay, so we're going to have to find all the way down to here. Alright, so we're going to start out here. We know that WX, this piece, and ZX, this piece here, just like what we did in example 2, those two numbers, the geometric mean is this one here, which is YX. So I set up just like I had from example 2. So I set one piece of my hypotenuse, which is WX, over the geometric mean equals the other geometric mean over the other piece of the hypotenuse. Okay, now I know that my WX, if I look over here, that's this piece here, that's 5.5. So I'm going to plug that in, 5.5 over, and then X y. xy is this distance here. I also know that one. That's my 8.75. So I'm going to plug that in. 8.75 equals, and then I'm going to write the 8.75 again over my xz, which I don't know that one, so I'm going to leave that one in there. So zx. Alright, so now I'm going to scoot this up so it's a little easier for you to see, since we're not looking at the picture right now. So then we're just going to go ahead and solve this. So again, doing our cross products. So we have 5.5 times our xz, or zx, whichever way you want to write that, equals 8.75 squared. Okay, and when I square that on my calculator, I get 76 point, we're going to round this to 56. Okay. So then from there, I want to get my zx by itself, so I'm going to divide both sides by 5.5. So I end up with zx equals, no, it's going to be approximate because we've already rounded here, approximately 13.9. 13.9. And then our label there, this is going to be feet. Okay, so I'm going to go ahead and put that here. So this is 13.9 feet, but that doesn't go all, oh, excuse me, let me go up to my picture. So I'm going to label this, this is 13.9, but that doesn't go all the way to the ground. I want to go all the way to the ground. So we said that this wx was 5.5, that's how tall our person is. So to find the distance all the way to the ground, I'm going to take my 13.9 plus my 5.5, and that's going to give me ZW, which goes all the way to the ground. Okay, so I'm just going to add those together, and I get 19.4 feet. And that is my ZW. Okay. Alright, let's try to do one more quick example over here. So for this one, for example 4, we're going to find x and y. X and y. And we have our triangles, we have PQR, PQR here. So PQ and RQ are legs of a right triangle, PQR. We're going to use that theorem 7.3 to write a proportion for each leg and then solve. Okay, so if we look back at 7.3, we have PR and PS. PR and PS will give us the y. So we have, excuse me, we have PR over our geometric mean, which is PQ, equals PQ over PS, which PS is the one adjacent. So the whole thing is 6. So this is 6 over y equals y over 2. Okay? The whole thing over the one adjacent. So cross products, we get 6 times 2 is 12 equals y squared. So then y equals our square root of 12, which is approximately 3.5. Oh, excuse me. Scoot down a little bit here. So 12 equals the y squared, so then we did the square root, and we get approximately 3.5. So the other one, we're going to be doing the whole thing again. So PR over, this time we're doing RQ. RQ equals RQ over the one adjacent, which is RS. Okay, so here PR is 6, so 6 over X equals x over our s is 4. So again, cross products. 6 times 4 is 24 equals our x squared. So then we're going to do our square root of both sides. We end up with x equals approximately 4.9. Okay, so we're just plugging those different pieces in and solving. And this is my little approximate symbol. I apologize. Alright, that's it for today. Have a great evening, and I'll see you in class tomorrow.